All right, so let's go ahead and kick this thing off. Gave you a few extra minutes to look that over. I'm happy to take any and all questions on the midterm. I had some comments of my own.
Okay, I was confused on 5 and 6 for number 1 because isn't that looking at like assignment and not
The true-false numbers 5 and 6 on question 1. Yes, you're absolutely correct. That is assignment, and it's actually a perennial problem / bug that C and C++ developers introduce, which is that they intend comparison for equality, but they do assignment instead. It isn't always a bug. Sometimes you can. I'd have to think a moment. Countless times I've used it legitimately, wanting that inside an expression where I want to assign a value, not a hard-coded value like 0, but you have some expression and that's assigned to B, and then you're evaluating whether or not B is true or false. The language is nearly entirely expressions, where a statement is nothing more than an expression with a semicolon. Now there are exceptions to that. When I create an integer int x, that is not an expression. Or if I create, we talked about structures a little bit. If I create a structure, I guess I ought to put this in. Let me see. So I'd call this a declaration, not an expression. However, there can be an expression as part of this. So if I say int x is equal to y squared plus 32, that is certainly an expression that is evaluated. But overall, I would say at the end of the day, that's a variable declaration. So it's not an expression in the sense that I cannot say, the format of an if statement is that I have some sort of expression here and then a statement here. This whole thing collectively is referred to as an if statement. The truth part of an if statement is itself its own statement. This expression here, just tons of stuff can go in there, but an example of things that can't go in there is the creation of a variable. Right. But once you accept that nearly everything in the language is an expression, then it becomes easier to swallow that x equals y is an expression and therefore can legally appear inside an if statement. What that evaluates to is whatever x ultimately is. In fact, it's legal in the language to do something like that, assuming that, let me see, I've already declared. So line 9 is legal. That should compile.
So is the reason why it prints out false then is because C with 2 equal signs 99 is not an expression?
Which one we're looking at? Number 5?
Yeah. And why it prints out false?
It prints out false because B is assigned to 0. I guess you have to understand what the result of this expression is. The result of this expression on line 9 is 99.
Okay.
The result of the expression B equals 0, the result of that expression is 0, which is false.
Oh, I got you.
All right, so what happens is, if you look at, if I ask you to evaluate this, if 5 plus 4, you do whatever the operator wants you to do, in this case the addition, it's a binary operator, you resolve that, and then the result of doing that operator is some sort of object that can be evaluated. Likewise, when you have b equals 0, first you have to evaluate that binary operator, and then the result of that happens to be b. And that's exactly why this works. This actually runs from right to left. Most things like addition and subtraction and all the operators we're accustomed to, you read left to right. But if you go to the very front of your exam and you look, what level are we at here? Level 15. So there's assignment, and then we see those funky ones like plus equals, minus equals. If you go all the way over to the far right column, you'll see that most of the operators in the language intuitively go left to right, such as addition and multiplication and so forth. But things like assignment go right to left, which means if I look at line 12 on my code on the screen here, the 99 gets assigned to W, then the W gets assigned to Z, then the Z gets assigned to Y, then the Y gets assigned to X, and then the result of that expression is X. Whereas if you're doing addition, 5 plus 6 plus 8 plus 10, you just simply start adding together left to right, and the result of that expression would be whatever sum you have at the end of that. Okay. Yeah?
So line 9 evaluates true.
Line 9 is true. Because anything in the language that is not 0 is true. Let me throw out some things here. Let's see. All right, so I did this last semester a lot more faithfully, and I kind of spaced it till I was a fair way through the grading, so I'm sure I missed some things that I wanted to point out. But these are just things that I saw many, many times over, and so I just wanted to make a comment on them. One of the things that I saw was people would write functions, but they would create their variables outside of the function. Okay. What I would refer to in this example here, I would refer to area as a global variable, and I believe there's a video bits on scope and visibility, right? So I would have talked about global variables there. They exist in the language because they have a purpose and have lots of valid use cases. However, as a general proposition, when you're writing algorithms, it's considered poor form to use global variables. And the reason is when you get to complex applications, and rather than dealing with your 30-line or even 100-line application, if you have an application that's 100,000 lines, a global variable means that there are 100,000 lines of code that are able to access that variable. And you may go, well, okay, that's fine, so what's the big deal? What if one of those 100,000 lines of code changes that global variable and you don't realize it? Because another thing is, if there are 100,000 lines of code, there are probably 24 developers working on that application. And this one developer needs that variable to be changed to this other thing to make his stuff work, and now your stuff is broken. So that's the danger of global variables, is by having it globally accessible and globally changeable, it's very, very easy to unwittingly introduce bugs. So the best practice is to, if you need a new variable, try to create it local to the area where you're using that variable. In this case, area should just be in the function. There's no need for that to exist outside of this function. If you need information, so another example would be height and width. A variant on this is people have not yet gotten comfortable with the idea of input parameters, and they'll write the definition just as it's shown there, but then in main, or I should not say in main, then somewhere else they'll create two global variables to hold the height and the width, and they'll totally ignore these input parameters, right? And what should be happening is you create your height and width in main, you get them from the user, and then you call this function passing those in as input parameters. So that's another way to avoid global variables, is you have these input parameters that you're able to pass around to your functions. All right, so that's that. I liked the answers that I got on this. So this one was asking you to write a function that, I don't know, did it explicitly ask you to use a for loop? The for loop would be probably the preferred way of doing it. The way I would have done it let's see. Oh, I'm just repeating the code that I see here. Actually, let me go ahead and repeat this code, and then I'll show a bunch of variants. So I don't have any problems with this code. I just thought it was interesting because there's so many different ways of implementing this fairly simple. Is it less than or equal? Lower plus I, is that right? Yep. And then they put a space. That isn't the way I would have done it, and I thought I like that. The way I would have done it is I would have said for int I equals lower, I is less than or equal to higher, plus plus I, and then I would have just printed out I. Yeah. And keep in mind, I'm not an asshole. I don't like grade on whether you know you got a space here, right? I just want to see if you know how to do it generally. Another way that I think I saw at least one person do it this way, which is also nice, is you don't even have to use a for loop. You could say while lower is less than or equal to higher, you don't even need to introduce a third variable I, right? And in fact, if you really understand how that postfix increment operator works, you can totally eliminate line 32, and you can just put the plus plus right there. And given that a while loop works on a single statement, I can get rid of the parentheses, and then I can reduce my code to that. Let's see. I bet I could probably even no, maybe I couldn't reduce it even lower. But yeah. So a few different ways of doing that. And this then speaks to the mantra that I keep chanting, which is you can't cram the course. The only way you're going to be able to get through this stuff is if you program, 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 because it isn't memorizing FOR, parentheses, and then there are two semicolons in there. It is that you've used it enough that now you start thinking in terms of it as a tool to solve a problem as opposed to something that you've memorized. Variants on this were fairly common, and this comes from not being entirely comfortable with zero counting loops. Okay? So what you can take as a recipe is if you want to do something, in this case, if you want to do it 6 times, you start at 0 and you go less than 6. That gives you 6 iterations. So think I want 10 iterations. That's fine. Start at 0, less than 10. You can use that as a recipe, and the kind of the comfort with it will come later. And the logic, of course, is that in this example, the range goes from 0 through 5, which is 6 iterations. Yeah?
No, it's not correct, but it still would print as it would just same line twice.
That is correct. It would. It would be a hexagon with an extra thick line if you're using your Sharpie. Yeah,
It's not wrong.
that's right.
It's just awkward place to add.
Now, what is wrong, and I didn't see it this semester, but I've seen it in previous semesters, is ignoring the instruction to write a loop, and they'll, assuming this was the problem, they would write move forward, turn right by 66 times, which is kind of defeating the purpose of why the question's being asked. Saw this quite a bit. A little bit of confusion between the definition of a function or the declaration of its prototype and actually calling a function. Okay? So this right here on line 19 is a function definition, and its very close cousin is the function declaration, which is identical except you just cap it with a semicolon. And one of the primary functional purposes of a declaration is if you have the declaration, then you can move the definition into an entirely different file. This is so the question to ask is, why is this information being provided? And the answer is because it provides sufficient information for the compiler to ensure that you use it correctly. So all the compiler needs to know is what it returns, what it's called, and how many and the kinds, the types of input parameters. And I probably made a comment about this before. As far as the compiler is concerned, this right here, this word lower, in a function declaration, I'm not talking about the definition, in a function declaration where I'm telling the compiler about what a function's about, it doesn't care about the names of these things. That's all the compiler needs to know. The name of the function, how many and the types of the input parameters, and what it returns. Now when you use it, you don't use int, void. What you use is an integer variable in the first position, an integer variable in the second position, and then it doesn't return anything, so you would not have something like a equals print range, right? Error. We told compiler that function does not return anything. If we did tell it was returning something, then we would most likely have something there on the left-hand side. It's not mandatory, though. Let's, if I create a function called, I don't know, u plus pi, and it takes a float fl, and then what it's going to do is it's going to return fl plus 3.14. I'm gonna know what so how I might want to use it is I might want to say, let me just put this, obviously none of this stuff's going to compile, I've got all this stuff thrown in here. If I was going to call the function, I could create a float t and then say t equals u plus pi, and I could stick 32.5 in there. Yeah, take 32.5, add 3.14, and the result would be assigned to t. However, this is fine as well. What happens is it returns a value, and you're not doing anything with that value. Here's another thing you can do. You just, right? Because what is the language? It's nothing but expressions. And that expression is just saying, hey, I'm a 5 and I'm sitting here. So you could also do, right? Now that's an expression. It'll evaluate it, come up with 9, and then it'll see there's nothing more to do with the 9, so it goes to the next line of code.
Or you can print it out.
No, it doesn't print it out or anything. It just does the math and then moves on. So if your function returns something, it's up to you whether or not you want to grab the result. However, if the function does not return anything, then it would be illegal to try and grab something from it. So, with all that as preamble, here is the hexagon again. The move forward function is being called, turn right by, and then this is fine. It's unnecessary. The variable degrees is provided in here. But you see all these types here are never included as when you're calling the function. All that type information is for when you're telling the compiler about what the function does, should you decide to use it. Once you use it, don't put any of that type stuff in there. All right, so that's that. Yeah, I guess I forgot that I already did the global thing in a previous photograph. So that's what this is exactly. Just throw that variable declaration inside the loop, because it's not needed outside the loop. Better yet, don't use it at all. Just put the number 60 in there. There's no mandatory reason to put a variable in there. Whatever goes in there, it just ultimately has to be an integer. Let me say it in terms that I've started using, any valid expression in the language whose type is ultimately an integer can go in there. So you can say 5 times 4 multiplied by 30 modulus 20. That, at the end of the day, that thing, whatever it evaluates to, is going to be an integer, so that's legal to throw in there. Or you could put a function call in there. If your function returns an integer, then put a function call inside those parentheses. Any valid expression that evaluates to integer can go in there. And a function call is part of an expression. All right, so I think that does it for my notes on that. I don't see any anonymous questions. Anyone have any questions on any of the exam things you want me to elaborate on?
Number 6, printing out the part after the same way.
The key insight here is to understand that a string is a collection of characters in the same sense that a vector of integers is a collection of integers. And it has functions you can call in it, like length and size, and you can use the subscript operator to get a particular letter out of that collection of letters.
Is that what that does? So when it says like first person and then the hard bracket with index on it, and the index were to be 0, it's pulling out the first.
Right, because counting always starts at 0. So first person sub 0 is the first character of the name.
So then it would print out J is not J. Then after it prints out the same.
Well, you would say, so walking through the algorithm, if first person length equals second person length, that's true, that's 4. 4 equals 4. So we go into the if statement, we say same length. Now we have the while loop. On line 8, we initialized index to be 0. So on line 13, while 0 is less than 4 and first person sub 0 is equal to second person sub 0. Now is the first character of first person equal to the second character of the first character of second person? Yes, so you do the body of the while loop, which is to add 1 to index, is 1 less than 4, yes, and is the character A equal to the character O. And the answer is no, so you fall out of the loop and you say first person, you say A is not O.
Gotcha.
Does case sensitivity matter for that? Like,
It does. So let me see. We looked at the ASCII code, haven't we? ASCII 2. Have I brought this up before?
Oh, the numbers for all of the different.
Every character has a number associated with it. Asterisk has 42. Uppercase J has 74. So when you're doing that check for equality of two characters, it's literally comparing these numbers for equality. And the uppercase letters have different numbers than the lowercase letters, so that's why they're not equal, or why it's case sensitive.
Okay. I just didn't know that when you did the hard bracket with an integer in there, it's checking that number of the
Right.
string.
So interestingly, since single characters are evaluated as these numbers, you can also do relational evaluation. You can say, is variable A less than, or character A less than character B, right? You can do a form of sorting, which is what you see. Let's see if I can show that. Yeah, so here I did a directory listing. It's 3 columns, so you read it left column down. So you can see that all the numbers come before the letters. And if I come to this ASCII chart, you'll see that the numbers are way down here at 48, 49, 50, and so forth, and uppercase A doesn't begin until 65. So these are all sorting these entries by the values of these characters here. Now we hit V and then lowercase a, and the reason is that uppercase V is 86 and lowercase a is 97. So lowercase a is greater than uppercase V. So that's why you see these directory listings in this kind of order, is because it's doing its sorting based on the ASCII values of the characters.
Does it do that automatically, or do you have a thing that sorts it like that?
Does it automatically. You can do a manual page on LS, and so I don't know if there are any options to change, to make it list kind of alphabetically rather than the way it is. There might be.
It's just what it says about.
Yeah. And so what if, so here's a question. So this is basically how computers work. So how is it that if I go to Google and I type Apple in lowercase letters, that it finds an apple with an uppercase letter? How did it do that match?
Like most searches, I'm assuming. Like,
Say that again.
by the popularity of searches.
Anyway, let's simplify the Google algorithm for a moment. The Todd Gibson version of Google, which is a really stupid version of Google.
Because Apple paid for that fund.
Is it because the URL is a lowercase?
You can make that argument, but let's say that it was searching on, like it went to the web page and it saw Apple written there with an uppercase A. How is it that they successfully matched those two? What would you do to make it successfully match? Yes.
How does it search like for lower and uppercase?
Yeah, A or A.
Yeah, but what if I did? But yes, you could do a search. You're on the right track. But what about this?
So make it case sensitive.
How is it that they make it case insensitive?
Oh, this is the whole shit.
Compare the numbers.
Oh, okay, so that's the right idea. They find the differences. How would you make something case insensitive? If I gave you two strings and I wanted you to ask if they're equal and be case insensitive, so that your algorithm would match this version of Apple that I've typed in with this version of Apple right here, what would you do to decide that they're equal? How do you do a case insensitive search? Well, the letters already do represent numbers. So what's the difference between uppercase A and lowercase a? It's 65 and 97. The difference between the two is 32. Difference between uppercase B and lowercase b is 32. For C, it's 32.
So you can just the same difference.
So what you do is you could go either direction. The way you make a case-insensitive search, if you're a computer programmer, is it's not magic. You have to take every single character and either make everything uppercase or everything lowercase so that then you get matches. That's how case insensitivity is done. All right, any other questions? Okay, so let's go ahead and move on then. Now we're going to make a major shift in the course, and what we're going to be doing is we're obviously going to be looking at more syntax and features of the C++ language, but what's driving our examination is how we approach problem solving. The problem-solving approach that most people are exposed to first and kind of gravitate towards naturally is something that I'd refer to as functional decomposition, which simply means if you are thrown a problem and you start thinking, how am I going to pull this apart, you begin thinking in terms of functionality and what are the functions that a thing needs to do. So if I have my music database program that I want to write, I need a function to be able to add a song to my database. I need a function to be able to edit it. I need a function to be able to print out my catalog, right? That's kind of what I think in terms of, and I could actually write separate functions for each of these. The approach that we're going to look at now is what I'd refer to as an object-oriented approach, and it is examining things in terms of how I would use them. And in fact, I'll even throw a term out here for you. And the reason it's valuable to look at how we approach solving the problem, whether it's functional decomposition or what I'm throwing at you now, is simply that it's completely necessary. So if we take scheduling classes here at Chico State, you have your pathways and you have your major requirements, the lower division requirements, upper division requirements, you have prerequisites. If me, as someone who's been programming for decades, was asked to sit down and write that application, right now I wouldn't have the slightest idea of how to start. Okay, I don't have enough information to write a program. So I need a way of how I'm going to approach that problem and begin ferreting out the bits and pieces of information until I can get it to a state where I have enough information and I can write code. As it turns out, there are exceptions certainly if you're a maverick software developer writing, I don't know, dancing hamster applications for the iPhone, and you're going to hope you're going to be a millionaire doing that. You aren't, but I'll let you keep your dream. I won't crush it. You'll find that after college. I don't even know what I'm talking about now. Just let me see here. Yeah. And so unless you're kind of you're a loner and you don't bathe often, and I'm getting sidetracked again. That's the exception. The rule is if you're a software engineer, you spend most of your time not sitting in front of a computer. You spend most of your time interacting with other humans. Sorry to say it. but that's the reality. Because most of your time is spent figuring out what the hell the problem is that you're trying to solve. It turns out that sitting down and coding is the easiest part of being a software engineer. Because once you know the problem, right, you're fluent in the language, you just sit down and you start cranking the stuff out. But what happens is you think you understand it and you get coding a little bit, and then there's just something that you've come across that you aren't sure of. So you have to walk away from the computer and you have to go sit down with the client and talk to them again and get answers to questions and adjust the way you were thinking about how you're going to solve it and so forth. So it's very much a human endeavor. And so I definitely want to include that as part of what we do. I guess what I'll do is I'm not going to have time to finish A13 now. We're going to have to spend the bulk of our time on Wednesday going through it. But I want you to go ahead and go to A13 if you aren't there already. And I want you to read this. So let me describe what you're looking at. So this looks like a fake email, and it is a fake email. And here's what I'm just barely trying to take little bites off of. There's a tendency in the computer science generally, and specifically the courses you take, where you'll get a problem, and you've certainly been getting that from me, which is write a program that does a for loop that does this and a function that does that. Okay. What I'm doing when I ask a question like that is I've done all the hard work. I've done all the interacting with that fictional human client and figured out what the problem is, and I've designed the solution, and I'm telling you, code up this solution that I've designed. And so what I'm trying to do is now that we're starting to understand the mechanics of the language a little bit better, I'm trying to pull away from that a little bit, and I'm trying to give you a very tiny taste of what it means to actually solve problems. So I could have not had this stupid fake email. I could have said, okay, write a program that does this, that, and the other thing. But what I want you to do is I want you to go through that process of figuring out what the solution to the problem is. And then obviously coding it up after that. So that's my motivation for giving you the information in this format. It's ill-formed. It doesn't tell you exactly what to do. There's a little bit of ambiguity. That's kind of what I'm trying to expose you to. So let me give you just, we've got 5 minutes left. I want to give you, say, 60 seconds to finish reading that. Okay, so also, I suppose this fake email dates me a little bit because not everyone may be familiar with what a web counter is. Back in the early days of the web, one of the major attractions to the web is that a basic web page is created using HTML, hypertext markup language, which all you need is a text editor, which could include really something like Microsoft Word. And you can just spit up text and you can create paragraphs and you can make fonts bold and so on and so forth. And it was tremendously exciting for people who were not necessarily savvy to be capable of putting up web pages. And the name of the game was how popular your web page was. And so you'd make it as gaudy as possible. It'd be the orange and green font, and it would have the dancing hamsters quite a bit. And you'd occasionally have someone who figured out sound, and it'd have a horrible repeating 5-second sound bite that would just loop. And in the corner there would be number of visitors since February 5th, and 5,643, right? And so that's the web counter, is every time someone would visit your web page, there would be some little program that would write that would increase that counter. Okay. So what we're going to do is we're going to try to analyze this problem in terms of what the solution is, in terms of how it's used. And rather than doing that now, I want to just stop a couple minutes early, and that's exactly where we'll pick up. Also, we're going to do a little bit of role playing. So I'm actually, to kind of bring it all home, I'm going to have a couple volunteers come up here to be my web counters. And I'll do a little role play on how it actually works. So I know that many of you are shy and would never want to do that, but I know that there are some folks who are hidden thespians. And I may even let you bust out in a song if you got some vocal chops. So think about whether you want to volunteer for the role play on Wednesday.